We consider the problem of planning contact mode sequences where contact modes correspond to if fingers are in contact with or regrasping a manipulated object, for example when turning a screwdriver. Our method, DIPS, plans contact modes informed by a diffusion model that outputs trajectories. We explicitly account for variability in the sampling that might occur due to model error. Given a contact mode, we run a trajectory optimization where different modes correspond to different constraints and objectives. We generate data for our diffusion model by sampling contact sequences from a defined prior and running our trajectory optimization. We train a diffusion model conditioned on initial state and contact mode. The diffusion model can sometimes output unrealistic trajectories, for example not having the thumb and middle fingers in contact in this turn mode. We train an additional discriminator to predict the realism of a trajectory to be used in our search. Our planner searches over a tree where different nodes correspond to different sequences. To expand the tree, we sample trajectories from the diffusion and use this collection of trajectories as an approximation of a distribution. We update this distribution by calculating likelihoods using our discriminator and resampling. We calculate costs as expectations over this particle-based distribution. By continuing this process throughout the tree, we are able to plan contact mode sequences. We evaluate on multiple tasks, such as sliding a card and turning a screwdriver, both in simulation and in the real world. In this task, we use a prior where all contact sequences are equally likely. This leads to sequences in the training dataset not sliding the card very far. However, through planning, we are able to outperform the data our model is trained on. We also show that a method like diffusion policy struggles with this contact-rich task. In this simulated screwdriver experiment, the goal is to turn the screwdriver as far as possible. We use a more informative prior here that sequences turning, then regrasping all fingers before turning again. However, we find that our planner is able to exploit the fact that regrasping may not always be necessary to turn the screwdriver further. In the real world, we are also able to plan useful contact sequences, avoiding unnecessary regrasps like the index finger regrasp occurring on the right to turn the screwdriver further. We rerun the contact sequence planning after each contact mode is executed. Here we show the diffused trajectories used in the planner. On the right, we show the planned contact sequence and one of the diffused trajectories from the set of particles propagated by the search. On the left, we show the execution of the first contact mode in each planned sequence. As stated before, we replan the contact sequence after executing the first mode.